Hi, everyone. We thought that we would just ask some questions before we begin. It's still have about 5 minutes, so if you are doing other things, feel free to continue. But just some quick questions. If you're running on Azure today, would you raise your hand? Okay, great. And now, if you are running on Azure in just a single region, raise your hand. Multiple regions? Okay, good mix. That's a great mix. Are you running on Azure in China? One. Okay. Azure Government? None. Two.
No, actually, a couple of folks.
Two. That's great. Okay. And how many people are running a hybrid on-prem and Azure deployment?
Ooh.
Wow. Great. This is excellent. How many are using ASR, Azure Site Recovery? Store Simple? Okay, great. We have a really good mix here. Azure Backup? Okay, cool.
Awesome.
This is fantastic.
Yeah.
Well, let's see. How are we doing on time? It's 8:57. I think we're going to give people 3 minutes. I'd hate to start and have people wander in feeling that they'd missed part of the talk. But it's great to see. So, and it's going to be interesting, I think, because some of the things that we're going to cover are pretty basic.
Yeah.
And it sounds like for some people in the room, perhaps those things will be stuff that you already know. But then we've tried to put in some things that are new as well.
Okay. Thank you.
Great. Perfect.
Yeah, so I think what we will do is the following. We will mark with green the new stuff that is coming,
Yep.
the announcements. Those will be relevant to all the folks in the room. And we'll cover the basics also in favor of those who are not as familiar with Azure as others are.
Sure.
Yeah.
Hopefully there's something in this for everyone. Now,
So look for green bullets.
yes. And we had been told that there would be something like, what? How many people?
Yeah,
registered?
500 people signed
500
up.
people. The room is about for 220. So grab your seat, keep it. But I also don't think we're going to have 500 at 9 a.m. I just don't see it happening.
Yeah, 9 a.m. is tough. It's like 6 a.m., 7 a.m. for me in Seattle. So I'll be wake up until we are done with this presentation.
Yeah, right at the end, if you ask questions, you're going to get a great response from us. Before that, we'll just have to see. So
if you feel that those green bullets, the new features that we added are useful to you, don't be shy, just clap.
yeah, there you go. All right, so why don't we start? We're right up on the hour. I'm Matthew Kerner. I'm a program manager on Microsoft Azure. It's a pleasure to be here with you.
And my name is Igal Figlin. I'm a PM manager in Azure as well.
And what we wanted to do was talk a little bit about Azure's regional strategy. But before we jump into that, we also wanted to show you a list of talks that you can go to this week that relate to business continuity. And there are some excellent talks here, so I would encourage you to check out any of these that seem relevant. We also will show this slide again at the end, but this, I think, is the only... Several of these speakers are lined up to show the same slide, so you'll see it in those other talks, but you won't find it anywhere else. So if you want this list, you can come up and get it from us afterwards, or photograph it now, or whatever. There's some good ones here. And we have at least one person, Greg, in the front row, who is going to be involved in some of this. I believe, Greg, you're doing the last one. Greg is kind of the Exchange HA expert. So if you have questions about Exchange, come up afterwards and waylay him.
Yep, we will leave a couple of minutes in the end for Q&A, and if there's something that warrants additional attention, you're welcome to come and ask.
Yeah.
Both of the mics are here in the hallway.
Yeah, and even throughout, just feel free to come up and raise your hand and ask a question. So then why don't we move on?
Let's go.
Yeah, let's do it.
Let's do it.
So what we're going to talk about today is how we look at Azure's regional strategy at the platform level and how that maps to what you might choose to do at the level of your application. We'll start with a very basic scenario. You'll see the green boxes along the bottom cover kind of taking a dev test application and then bringing it to production and then scaling it globally, adding capabilities. And we'll cover the concepts and capabilities that apply at each click along the way. What we won't be doing is we won't be going through code snippets with you, and we will not nor will we talk about specific Azure regions. So if those are the things that you came for, you may decide that you want to go find another talk because we won't satisfy you. But if this is the stuff that you wanted to see, that's exactly what we're going to cover.
One another way to look at it is essentially building your application. You start small, potentially taking your app from test, from development, going to production and growing the customer base, going to your first million customers and the next ones. Or potentially you have some enterprise app which you want to scale up. So those points can also be seen as points in lifetime and life cycle of the application as it grows, as its customer base grows, and you need to scale it up, both in terms of size and availability.
And so what you'll see is that as we elaborate on the application design and on the concepts that we're introducing, the application will become more complex, and it probably in some ways becomes more costly to run, but your resilience to different classes of failures will increase to a certain point, and then past that point, expanding in any additional direction will get you compliance and regulatory type benefits, but probably not technical benefits in terms of availability or failures protected against. So why don't we just look at one alternate way of seeing this framework. This is the sort of view of Azure's regional hierarchy, where we start sort of at the outer layer with the cloud, the geo, and then inside of a region we've got fault domains for local HA. And so we will talk through these as we go. I'm not going to spend too much time on this, but this is just another framework for looking at this problem.
Cool. Let's jump right in. Yes? Yes, it works. So let's start building the application. I'll use the same kind of template across those slides. So on the left side, you will see an iOS application. On the right side, you'll see a fairly similar PaaS application. And the difference is that with iOS application, you need to manage your own OS. You need essentially to manage your infrastructure. With PaaS application, you are getting the environment managed for you. You are getting the updates and some additional system services which will help you to run the application, like easier scaling story, easier deployment story. So we'll have those two apps going with us to the slides. This slide shows a fairly simple app. I'm just testing it out, developing it. I just want to see how it works. I have some front end. This is the first line, some middle tier, and some data tier, some back end. I don't care in this first application about availability. I really care about having quick iterations. I want to tear down the environment fast, redeploy it fast, experiment with it, try new things. I don't care about scale and the data. I can probably I don't care about this as well, because this is just a test. I can iterate fast, try it out. In green one, so one of the things that is relevant to this simple configuration is single instance update notifications. So already for some time, folks who are running iOS on Azure have experienced getting notifications when infrastructure is updated. This was true for single instance application, and it's really, single instance applications are limited from the availability perspective. They don't allow you to get Azure SLA. But still, one of the things that we could do with those applications is to provide maintenance notifications. So we are working on enabling similar notification also for multi-instance. And our hope is that even more advanced applications that use multiple availability tiers will get the notifications. So it's been gradually rolled out. Some of you might experience this pretty shortly. Some of you will experience this along the way. But you should see those coming to production in the future, in the short future.
Actually, one of the things that we had heard from customers is that they wanted to run multi-instance tiers of their application using availability sets and multiple instances. But by choosing to use availability sets, they lost the ability to receive maintenance notifications. And so some customers decided actually they preferred the notifications over the HA associated with the availability set. And so they would choose not to use availability sets, which from our perspective is awful, because it means that every single platform update that we do has the potential to take down the entire application. So we're pretty excited to get this notification going, because I think it's going to unblock many customers and give you sort of the best of both worlds.
Yeah, we'll talk about this a little bit more in the next slides.
Sure.
But this is a really basic scenario. Let's take a look where we are.
And so we're all the way on your left side of the slide, where we're just in a single instance world. And really the only concept that matters at this point in time is this notion of automatic recovery or service healing if there's an infrastructure failure. Servers fail all the time. Sometimes other components could fail, like a top-of-rack switch or the power supply to a rack, and we could lose a bunch of VMs for that reason. And when that happens, the system that we run in the data center automatically notices this, and it heals this VM to another healthy host. And so that automatic service healing applies even to single instance. Of course, since it's single instance, your application will be unavailable for the period of time that it takes us to boot that VM on a new machine. And so you should just be aware of that, but this is something that sort of we do by default under the hood.
Let's take the next step in our story, in our journey. Let's look at the real application. This one is much more real. This is production application, and there are multiple tiers of complexity here that warrant our attention.
And I think this is probably the biggest single step that we're going to take in the talk, going from single instance to multi-instance, so we'll probably spend quite a bit of time on this particular picture.
Yeah, so feel free to ask. So once again, on the right side, you have PaaS application. On the left side, you have IaaS application. Just two examples of the similar app. One first thing that we want to deal with when going to multi-instance and creating a more evolved application is fault tolerance. We want to make sure that no hardware failure can impact experience of our customers, the customers who are using this application. So for that purpose, we have a concept called fault domains. When you create VMs, when you create services, those are allocated to fault domains. Those are allocated to the fault domains when the VM is added, and this is done pretty much transparently by PowerShell commandlets or the portal. However, you can see within the portal which fault domains were allocated to each application. So when you terminate VMs, you should do so in accordance with the right fault domains. You might end up in a situation where you terminated VMs and left only with one fault domain. So this is one thing to take in mind when creating and managing an application with high availability. So fault domains are alternated, and one piece of big news, we are adding support for 3 fault domains. In the past, we were providing support for 2. We are adding the 3rd one. And why is it important?
3 fault domains is interesting for many applications that are stateful. If you're running SQL always on and you want to have, let's say, a witness in a 3rd fault domain, by having that 3rd fault domain, you're going to be able to maintain availability even when of your multi-replica tier, even when one of the fault domains failed. It used to be when you only had 2 fault domains that if you were unlucky enough to lose the fault domain that had 2 instances, the 3rd instance running would not necessarily stay available. The same thing would happen if you were running Cassandra or any other quorum-based workload. We use Paxos for many of our platform services, and so we need to spread our instances across at least 3 fault domains, and so we do that, and now we've made this available to you. And the way that you get access to that is through the new IaaS API. Actually, Drew and Mahesh are giving a talk concurrently with this one, doing a deep dive on IaaS with Azure Resource Manager templates. And so one of the configuration options that you have is to designate for an availability set that it's spread across those 3 FDs. So that's how you get access to that feature.
I know that many of you folks are running production applications, but I still want to make sure that we are all doing it right. One important thing to do when running multi-instance application is to define availability set. Availability set will tell the platform that those 2 VMs are connected together. Without availability set, we cannot offer SLA. We don't know how to manage the system in such a way that at least some of the VMs will stay always up. So the hint that you are giving us is defining availability set and saying, okay, all those machines are part of the same availability set, so you guys should consider it from the fault tolerance perspective. But this is not the only perspective. And by the way, you can see defined on the slides as AS1, AS2, availability set 1, availability set 2. In PaaS world, those are roles. So when you're defining web roles, worker roles for the application, potentially some more roles within your applications, you will define those fault domains allocations based on those role definitions or availability set definitions. But as I said, this is one point. Another point that we need to take into account is update support. And update support both for infrastructure This means how infrastructure is updated underneath without impacting the uptime of the service. And update of your application. When a developer or when an owner of the application wants to update it to the latest version, he might do so in a way that leaves the availability of application intact, that keeps the customers running. So the notion we use here is update domains. We support up to 20 update domains for iOS. I think there was some partial support in the past. This is getting formalized. And once again, the talk about iOS will describe how to add those 20 update domains. But what it means for your application is that the amount of applications that will be taken down simultaneously while infrastructure is updated is limited to one update domain. If you decided that your application has five update domains, which is, by the way, default, right?
Yeah, actually, I had coffee with Drew this morning, the guy who works on this, and we were talking about update domains. That's what I talk about in the morning over coffee, and he confirmed it used to be that with availability sets that they were fixed at 5 update domains and 2 fault domains. Those are both variable now in the new template modeling language. So you can define an availability set that goes up to 20 UDs, which is excellent because now it means a very small slice of your application would be taken down at a time during a platform update or your code updates, and so you get much more control over that.
How much? 1 divided by update domain count. Perfect. So if you have 20 update domain counts, that's 1 divided by 20 size of your availability set. So really could be up to very small piece of your applications that goes down when infrastructure is updated. So folks, feel free to come in. There are some more places
There
here.
are plenty of seats. Come sit close to us.
And I don't bite. Matt might bite, but I hope you won't. But it could happen. So update domains are located in the same way, in the rolling fashion. So any new VM you are adding will get the next UD number. So if you have 20, you'll get the new VMs added to the update domains in an increasing order. And once it reaches the top, it starts from the beginning again. Once again, you can query that using commandlets. You can see it in the portal. Make sure when you're deleting or adding VMs, you are taking this into account. You might end up with limited amount of update domains after multiple addition deletion operations. So that's definitely a consideration when designing management for your applications. From your perspective, when you are thinking about your strategy to update the application, having multiple update domains and observing the update domains is also a good idea. This will ensure that if there is a infrastructure maintenance in the background, it won't interfere and will not cause availability impact because it uses the same scheme of update domains. And one last point that I wanted to mention here about how this can be used is auto-scaling. Scale sets can be used for your applications, and those could create new VMs in the availability sets or remove the VMs based on the load. And it's important. One of the questions that I'm hearing is, why is it worse to move to the cloud? And this is probably one of the big advantages cost-wise, right? This is really a huge thing. You don't have to pay in advance for all your capacity needs. Furthermore, you don't need to pay for your capacity needs across the day. You might be scaling up and down your application. I hope. So if there are folks here in the retail industry, I hope you guys need more capacity in the holidays. And this could be achieved with scaling. So this is an important factor. It's not to be ignored. When your application needs it, it should be able to burst based on memory consumption, based on CPU consumption, based on other factors. And when you're designing even simplest application just entered into production, you might want to take into account future scaling needs.
And out of curiosity, and it may be that you know this or you don't know this, and it may be that this is not even a reasonable measure, but if you just think about the workloads that you manage, how many people here manage workloads with average CPU utilization above 80%? Very small number. Above 10%. So there's a huge opportunity right here for auto-scaling on infrastructure that you don't have to own and depreciate all the time.
definitely.
We'll take care of that.
Yeah,
for
if
you.
we are comparing that to, if you're comparing that to owning a service, that's
Sure.
definitely a major difference.
Sure, sure.
Uh,
And by the way, the number of hands that we saw go up, that's totally consistent with every single time we talk to people. The vast majority of workloads are cold the vast majority of the time.
Definitely, when you define an application in production, you may want to fence it around and make sure that outside world cannot connect or cannot inject between your tiers. So using VNet for that purpose is a good practice. So in this example, both IaaS and PaaS application have virtual networks defined, and those will fence your application from outside world. Will use virtual addresses in order to communicate within the application, while externally you could define those holes inside the VNet in order to be able to access the application. What about data, Matt? What should we do with data in this scenario?
Yeah, it's an interesting one. So in this example, we're running a multi-instance application, but so far that application is solely hosted in a single region. So it would make sense that the data would also be in that region, and there are a variety of different data tier options. Of course, you can roll your own. You could run SQL in a VM, or Cassandra in a VM, or your own database of choice in a VM. Or you could use our database service, Azure DB, where we automatically manage a database for you, and we will then replicate that database across multiple physical nodes. Every time you make a write, that write will be replicated synchronously. And so that data will be highly available within the scope of the region. We do the same thing with Azure Storage, with an offering that we call locally redundant storage, or LRS, which again is three-way replication that's synchronous before it's acknowledged back to you. And so you have a variety of different choices around data within the region. What we'll talk about next as we add another region into the picture is what do we do with data once we now have two different regions to contend with. And that becomes a really interesting problem.
Awesome. So to summarize this, I think it's important to note, and I noted that, I'll note that again, in order to get SLA for your production environment, you need to use availability sets and more than one instance. Just defining two VMs for a production application is not enough. We won't guarantee SLA, we won't be able to guarantee SLA on that one. In order to guarantee SLA on your production app, you need to define availability sets that make sense. And don't just shove everything into single availability set. Those should represent the functions within your app in order for the system to function correctly. So this is a hint for us about how the application is built. And based on that, we have mechanisms that will ensure the SLA for Azure. At least two instances within availability set are required to run to have SLA. And once again, you know what? I'll go to the previous slide for a moment. Once again, major change that we had is notifications that previously were not available for updates of multi-instance. We are gradually adding the support. It's still in the early preview, but this will go out and will be exposed as we go for wider sets of customers. So you shouldn't see notification happening updates happening in the background without your knowledge. And I think this is the first time we are rolling out this functionality for PaaS. By the way, how many folks here are running IaaS versus PaaS?
IaaS.
IaaS.
PaaS? And that's
Cool.
also common.
So we have
common.
we have a good mix. So I hope this is going to be useful for you guys in planning planning the updates.
So, Igal, if you jump back to the next slide, I think the interesting thing here is now we've added multiple instances, and let's say we've added multiple instances at every tier of your application. Leaving the data portion aside, the compute portion has now gone up in cost by at least a factor of 2, because we went from one instance to at least 2 instances, and probably it's gone up by more than a factor of 2. But what you're gaining in exchange for that additional cost is resilience to a variety of failures that could happen in region. I'm sort of glancing at this fellow Greg sitting in the front row because Greg works on Exchange. And the Exchange team decided that they're going to offer a service that's spread across multiple regions. And that is going to be the main way that they achieve availability is by having the ability to fail over across regions. And so for some applications that choose to go multi-region, you're not going to end up deploying multiple instances within a single region because you're going to end up paying that cost across multiple regions anyway. And so you may as well get the resilience across multiple regions. The challenge there is figuring out how to deal with the latency across regions and how to make that work for your particular workload. I know the Exchange team has done a ton of investment over time to make it possible to run solely across regions and just get redundancy that way. This is an option that works for many applications that were not designed that way from the start, or where it would be difficult for the workload to serve the customers in the way that it needs to if it were to spread across multiple regions. And so right now, sort of the concepts that we're talking about are all about replication and redundancy within the scope of a region. Synchronous replication is easy within a region because we're giving you less than 2 milliseconds round trip time on the network. So you can simply do synchronous replication with out-of-the-box technologies and it will just work. Now when we talk about multi-region, it starts to become a little bit more interesting and challenging.
Thanks, Matt. So this is going to be definitely more challenging from the data perspective, but not only. Let's take a look at what do we need in order to scale globally? What do we need in order to scale across the world? And by the way, why do we need to scale across the world? Why it's not enough to grow within the region?
Well, it's interesting. I mean, I think the big difference going multi-region, again, is the latency between regions. And that latency exists within the scope of your application. If you're going to have, let's say, a web tier talk to a middle tier in another region or talk to a data tier in another region, you're going to pay a long round trip time for that communication, and that will be visible to your users. Also, your users are accessing your front end from someplace in the world, and if you can deploy in a place that's closer to them, they're going to have a much better experience. And so you've got to think about both your user proximity and then the proximity between the different portions of your app that are talking to each other. And that's where putting all of the right pieces in the different regions around the world becomes important for giving the right performance experience to your customers.
Yeah, so as we dissect the needs for global scale, we first of all see the need in multiple regional deployments. So we see deployments going out separately to different regions while still sharing some of the tiers, some of the data, of course, and some more. We see the need to create a disaster recovery story. If one region goes down, the other region should seamlessly, hopefully as seamless as possible, continue to work and provide service to your customers. We need to scale. There is a question of balance between the regions when customers are using your applications, accessing your application. Which region should they be sent to? Definitely to the closest one, but what if it's overloaded? So a lot of interesting questions arise. Let's dive into the technical side. Let's see the drawing. Let's see the figure. Let's see how it actually works, and we'll go over all the details. Yes? Could we see how it actually works? No? Yes?
There we go.
Yes, we can see how it works. So on the right side, you have 2 regions for PaaS. On the left side, 2 regions for IaaS. So still, we are sticking to 2 applications. It's a little bit confusing, but that's the idea. So in the conversation, I'll focus on the IaaS one. I see much more folks here that are using IaaS, but actually simpler concepts apply to PaaS. So let's start looking into this. So first of all, when we are looking into 2 regions, we need to clearly understand what is running within each region, what scale is needed within each region. And one of the concepts that we hear a lot from our customers, and we definitely encountered that when we designed our application, is the concept of stamps. Mm-hmm. It's in some point of time within the life cycle of your application, and hopefully this is where your application has already has gone global, large, has many hundreds of thousands, maybe millions of customers. But one of the problems here is scale, and you will start finding bottlenecks in your application. You will not be easily add another instance to the application because something is blocking you, some bottlenecks that you encountered. So it will be a slow process of scaling your application. One concept that is pretty common, the stamp concept, is, you know what, instead of going and chasing every bottleneck, what about just taking your application, the stamp, and replicating it potentially to another region, or maybe even within the region. In some cases it makes sense within the region. But this kind of growth will probably be easy from the efforts perspective. We won't need to solve all the bottlenecks. We will need to, of course, to manage the traffic, how it gets to each stamp within your application. But it's a concept that really much simpler when you go to this hyperscale. And this is also a reason why it's not necessarily more costly to go to multiple regions when your application has the right scale. Because anyway, you might need to have those stamps, and you might as well place the other stamp within the second region. So in this example, region 1 and region 2 are the regions we are using. Within each region, we still have fault domains, update domains. All the complications we discussed earlier still apply. Same concepts. But now you need to take into account multiple regions and how your app getting traffic from customers within those multiple regions. One feature that we have useful for this kind of application is multi-region virtual networking, wide VNet. This will allow you to define internal communication between components of your application across the regions. This will also actually allow you to create virtual appliances in order to facilitate the communications between your VMs across the regions. And as you can see on this drawing, Traffic Manager on top is managing essentially the customers, which direction do they go, region 1 or region 2, potentially based on proximity or availability. And within the region, there is load balancer. And it gets me, by the way, to another point that I didn't mention. If you want to scale up or down your VMs within the region, you might need to reconfigure or to configure correctly the load balancer, so it would be able to load balance to the new endpoints. That's another consideration. So within each region, you might still have the same scale-out stories that you had previously. And another thing to consider is content delivery network. How many of you guys are using CDNs? Cool, a lot. What are CDNs? Do you know what CDNs are?
Well, yeah, so it's a network where you've got dozens or hundreds of points of presence around the world, and those points of presence are caches. And so when a user wants to retrieve a piece of static content, they'll use a special domain name that will automatically map to the closest point of presence to them. That point of presence will turn around and go back to your origin, let's say an Azure storage account, just as an example, and retrieve the piece of static content, and it will then store it within the point of presence, and whenever customers go to retrieve it, the point of presence will serve from its local copy. The nice thing about that is that users get lower latency. Of course, the first user who effectively warms up the cache for everybody else is going to wait a little bit longer than they otherwise would if they were to go direct to the origin. But every subsequent user is going to have a great experience. And this is also a great strategy for reducing cost, because if you think about it, let's say that there are 100 points of presence and 1 million users who are going to access content. Well, you might end up having to pay for 100 storage transactions against the origin, but then the million minus 100 requests that come from users are all going to be served by the CDN, and typically the CDN will not charge per transaction. It'll just charge for bandwidth, and so the bandwidth cost you would have paid anyway, and so it can end up being a much cheaper proposition than it would have been.
Awesome. So one new feature that I would like to announce here is region pairs for compute. So one of the changes that we did for our infrastructure is to make sure that certain infrastructure component is not being updated in 2 regions at a time. And this is why it's useful for you guys. It's useful in order to plan your deployments. As long as your deployments reside within the same region pair, so using the region pair concepts, you know that the same components being updated by infrastructure is not updated in 2 regions at a time. And this is a way for us to ensure availability, even in case of severe underneath bug or severe impact. We don't expect this to propagate immediately to all the environment, and we will still have at least 1 region out of region pair up. And once again, this is not a scenario we hope to use any day soon. This is not a good day scenario. A good day scenario is fault domains, update domains. Those should protect you. This is a disaster scenario. And still, in order to protect yourself from a disaster, we are designing region pairs that are completely independent. Even on the software perspective, when we do the software updates for the infrastructure, we will keep them independent.
How many people were affected by the November 18th disruption of service in Azure? I expected to see many more hands go up, actually. So first of all, our apologies. We run an enterprise-grade service, and we do not meet your expectations when we have an outage that affects many parts of the world at the same time. We've made many changes since then, both to address the downtime source, which was an update that we rolled out globally in a very short window of time, and also to address the communication problems that you may have seen where we didn't have the status dashboard up to date and where we were not active on social media, so people felt like they were in the dark. Both of those things are unacceptable. So we've addressed a bunch of things there. What we're doing now is we're being very transparent about what our update strategy is, so that when we update, we will update in a non-overlapping way across these regional pairs. You can deploy across these regional pairs, and then you will be protected from any kind of bug that we happen to ship that might occur during a rollout. Of course, it's possible that there's a bug that manifests in a different way. We had a leap day bug several years ago, and I know that both Google and Microsoft have had certificates expire in such a way that it affected customers. Those things can still happen globally because time is a global variable that all instances share in a consistent way. So we work very hard to prevent those things from happening, but it's possible that such a thing could happen. To the extent that we can mitigate bugs by rolling out in a gradual way, we do that with respect to these regional pairs.
Yeah, so availability is very high on top of our minds. This is something that we look into in every feature design, essentially, that we review, in every feature we plan. So our hope is that regional pairs will allow us to avoid any impact from immediately manifested bugs. One another concept that I wanted to share with you here about regional rollouts, one another scenario is flighting. Consider the following need. When introducing changes to your application, you might want to see what is the customer acceptance. You might want to flight it for a limited period of time and measure customer experience using telemetry or maybe some kind of direct feedback. So just by adding potentially another region for your application and sending maybe 1% of your traffic there, this could give you an interesting estimate about acceptance of the new features, of the new changes, potentially even stability of your new changes. This could be part of the rollout pipeline where you start from creating a new region, a new stamp, within one of your regions, trying it out for looking for customer feedback, looking for customer experience, and potentially updating the rest of your stamp. So this could be for limited flights to gauge how customers accept or will accept certain feature, certain change in your application. So flighting is a pretty common concept, and as long as your application supports regions, it's pretty easy to try things out. Just another stamp of your application with limited traffic, limited customer traffic. That's how we flight.
That's right.
That's what we do for our features.
That's right. That's right. And Traffic Manager gives you a variety of policies. You can do a geo-proximity policy. You can do an availability policy. You could do just round robin, or you could route a certain percentage of traffic to one place and everything else to another place. So you set that policy on a Traffic Manager endpoint, and then you'll just be able to direct users in such a way that you achieve whatever goals you may have for that.
Mark, what about data in this configuration? This sounds much more complicated here.
So to me, the biggest challenge dealing with a multi-region deployment is to figure out how to manage the latency between the regions, and specifically the impact of that latency on your data tier. If you think about, let's say, a traditional OLTP type application, the time that it takes to replicate data synchronously to have a consistent transaction across regions can be prohibitive for the user experience, and so you can't just naively, let's say, take a database and run SQL always on across regions and expect that you're going to give customers a great experience. So there are a couple different strategies here. One thing you can do is you could say, for some workloads, it's fine for me to access my data across regions because I have a batch-oriented way of processing data, or my users don't expect things to complete quickly and I don't need to, and so I can just keep things synchronous and I can keep things straightforward, and it's easy for me to manage that way. That's certainly one option. A second option is you could decide that your workload is able to deal with an eventually consistent model. And so you can have independent multi-master data stores running in each region, and you can write some logic to reconcile those, like the last write wins, or this such and such region always wins, and it might be that that works for some workloads. A third thing that you could do is you could partition your data across regions such that any data that's written is mastered in a single region, and all of the rights to that data will go to that region, and you typically would then keep those rights to be sourced from that region. So each region is writing to its own local copy of the data. The data is partitioned so there are no conflicts across regions. And then you could asynchronously replicate those rights across regions for disaster recovery. Of course, as soon as you introduce the notion of asynchronous replication, you're dealing with a non-zero RPO. And so you have to be okay for your business with the potential for some data loss if there were to be a disaster that affects a region. I will say this is a very workload-dependent decision, and some workloads have some get-out-of-jail-free cards. Like, for example, you might be able to replay data because you have some other copy of it somewhere else, and that other copy is the master copy, in which case it's very easy then to reason about how to deal with data because you don't have to worry about RPO anymore because you can just replay it. So then you could have regional copies, and if you were to lose a region, you'd replay, and perhaps you'd lose some less important data, but you would maintain the key data that you need to manage. So there are a couple different options on how to do this. Azure offers some mechanisms that make it easier for you to implement the option that you choose. So when it comes to Azure DB, if you opt for the premium tier of database, you can configure active georeplication, which will do asynchronous replication across the regions of your choice. By default, the regional pairs that we have listed in the table are the ones that are selected. That way, if we have a failure that affects an entire region, all of the services that are doing replication or that are offering you the ability to do secondary deployment are coordinated across the database tier, across the compute tier, across the network, et cetera. Azure Storage also offers a model. We mentioned before locally redundant storage. There's also geo-redundant storage, which asynchronously replicates another 3 copies in a secondary region, again corresponding in the table on the side. And you can even opt in for RAGRS, which gives you read-only access to the secondary region. There, the recommendation would be, and this can be tricky to do, so take it with a grain of salt, but the recommendation is to trickle reads to the secondary region so that you can confirm that that secondary account is working the way that you expect, so that in the event of a failover, you wouldn't be surprised if there was a problem over there. You would already have seen it and dealt with it. There's an API that storage exposes that lets you query how far behind the secondary region is. So if you want to implement some RPO policy, you can do that. You could, let's say, throttle writes to your application until storage has caught up with whatever you wanted to have replicated before you accept new writes. So there are a variety of options at the data tier. The last thing I'll say is that some data is read-only. And for that read-only data, it's very nice to create copies in each region around the world so you can access it. What we sort of imagined when we drew this diagram is we would partition data regionally. Each region's partition would be mastered in that region, and we would do asynchronous replication to a secondary region for disaster recovery purposes, again with a non-zero RPO. And that's the model that we imagined both for Azure DB as well as for Azure Storage in this particular picture.
So one thing to consider regarding region pairs is, of course, the latest version can be found on the web in our documentation. You should consult that one. I think the dump here is as of today, but regions are added. New regions are being brought up, so you might want to consult the documentation. But one thing to consider once we add multiple regions is how do we simplify? What is the simplest way to get our data set up? I'm back to IaaS now. So one of the ways definitely is to bring your own SQL server, run it on top of IaaS, configure it, run it, potentially replicate it. But probably an easier way is to use Azure DB. Azure DB premium tier will give you the replication features, the availability features out of the box without multiple complications that you will encounter otherwise setting up SQL Server. This will save you time and effort. So when you're building your application, I would propose to consider SQL Azure first, just to simplify the things around, especially in such a design when you need to synchronize data between regions. And once again, there's no out-of-the-box explanation here. Use this one and you will always be covered. This is really dependent on your data, really dependent on the time it takes to synchronize your data. In some cases, you might want to partition your data so that only relevant data for a certain region is local and potentially some limited set of global data exists. So all those are the things you'll need to take into account when designing your data across regions. Once again, I urge you to look into the list of availability and SQL breakout sessions in the event and see if you can find something interesting. This is a pretty wide topic. We won't be able to cover it all right now, but this is definitely an area to double-click when you are exploring multi-region support for your application.
Question.
Can you use mic, please?
Just a quick question.
Sure.
On the active geo replication support, did you mention that's more or less built in across a region pair? Or is it also possible to use it across different regions?
So the question is, do you have the choice for active georeplication, or is it built in?
Yeah.
And the answer is it varies depending on the database SKU that you choose. If you choose the premium database SKU, the very top tier, you get to choose which regions you replicate across, and it can be more than 2. Okay. You can have a
so you're not
multi-way
restricted to region pair.
Exactly. The region pair is just the default that's there. For the SKUs that are the more basic SKUs, we have some more basic recovery features available, and they're all documented on MSDN. The RPOs are different, et cetera. And so in those cases, we do use the default pairs.
Thanks.
One thing that I would propose to consider is the availability story. We explicitly optimize for availability across region pairs.
Yes.
So even if you go outside of this guideline, it is possible to use different pairs, but availability-wise, you'll need to manage it separately. So our proposal would be to stick to region pairs unless you have a good reason not to.
The other thing that I would say about region pairs is there's a very important question, which is what happens if there's a disaster and you need to fail over? To what extent is the platform going to be responsible for implementing that failover versus you implementing that failover? And the fact is, for many services, you're responsible for implementing the failover. And even when we implement the failover on our own timeline. So the RTO may not be what you expect it should be for your business. I'll give you an example. We had a set of hardware failures that happened in such a way that we nearly lost data in a region at one point, but we knew that we could recover it given a little bit of time. So we took the time to recover the data, and there were many customers who were happy about that, but there were some other customers who said, look, for my business, it doesn't matter if the data is lost. What I want is high availability. I don't care about durability. And so I would have much preferred that you failed my account over. And since we don't give you control over that switch, those customers were stuck and they were waiting for us. Now we've unblocked that to a large extent by having the read-only secondary account that you can use yourself, but you need to very carefully look at how we manage failover of the resources that we control such that you can achieve your own RPO and RTO goals. And there's a talk by Hongfei Guo and Patrick Wickline. I don't think it's today, I think it's later this week, and it's up on the slide that we'll show again at the end on all of the related continuity talks, which talks specifically about this issue and what some of the strategies are that customers use to implement their own failover on top of the primitives that the platform provides, such that you can achieve your own goals. And that's something to look at very carefully.
Cool. Let's go ahead.
So what we
summarize where we are.
So what we've added when we went across multi-region is we've sort of expanded the scope of replication to asynchronous instead of just synchronous. And since it's asynchronous, we've had to talk about disaster recovery because we now have a non-zero RPO. And then we've also introduced the notion of user proximity with multiple regions around the world, and you can use traffic management to route your users to the right place. We didn't actually, if you look back, traffic management is also covering the multi-instance case where you've got a single region. We didn't talk about it previously, and the real reason you might consider using traffic management, even within the scope of a single region, is to achieve the flighting that Igal mentioned previously. So you might do 2 deployments in a single region, and you might route, let's say, 1% of traffic to one of those deployments, and then that's the deployment that you would update first. You could then look at the behavior of that deployment with a new code version and make a decision about whether you want to roll that out to your whole deployment. And so from a sort of management and deployment perspective, you might choose to use Traffic Manager in a single region typically the use that we see is across multiple regions. So there are a couple different cases there.
Cool. New markets.
Yeah.
Why do we need new markets?
New markets is interesting. We have now dropped off the end of the technical spectrum, and we have entered into this discussion on jurisdictions, tax, and regulatory concerns. And we actually run 3 different clouds. There's the public cloud, which has multiple geographies. And within the scope of the public cloud, when you put data into a geography, our promise, which is documented on the Trust Center, is that that data will remain within the geography. These geographic boundaries are often, they often include multiple nations, but they're sort of the typical geopolitical boundaries that most of our customers tell us correspond to the things that they care about in terms of jurisdiction. So you put your data into a geo, we keep that data within the geo, and then we comply with local law within the geo. So if law enforcement comes to us with a request to hand that data over, we will comply if it's a valid order. You can actually read about that on Microsoft.com/transparency, where we publish the numbers on how much this happens in every single jurisdiction in the world where we do business. And so in public cloud, geo is about data residency. We also have Azure Government and Windows Azure in China, which is operated by a partner in China called 21 Vianet. And both of those clouds are physically isolated clouds with a separate set of personnel who operate them. And in those cases, they're intended to serve particular markets that the public cloud can't really reach properly. And so as you think about your multi-geo strategy, you can look at that within the scope of the public cloud, or if you have a customer segment in China or a customer segment in the US public sector, you could serve those customers from one of these isolated clouds using the same programming model, the same experience, et cetera. So the intent is to make that as easy as possible. And so that's really where we go when we start talking about multi-geo.
Yeah. So the example here is only for IaaS for the purpose of brevity, but from the design perspective, it just needs the same design for the new markets as you have for your public cloud. So same regional strategy probably within China or within Microsoft Government Cloud. Thing to consider is where your data lives, what data you replicate. There is still access between the clouds. There is still connectivity, but you may need to carefully consider what exactly is being replicated. Probably it's not really a good practice to put them all in the same VNet. Probably networking-wise, you want a very clear disconnect between those guys. From the data perspective, you definitely want to consider what goes where. But it's still possible to add regions, which are kind of disconnected regions, and have both jurisdiction and sovereignty issues resolved in that way. This is not about increasing availability. This is only about increasing the access, adding access to the new markets. And 2 new markets in this case are either government applications, government agency which could use your software, or potentially China market. We will definitely add we are planning adding additional markets in the future. Wherever those issues exist, those scenarios exist, you should consider using those new markets.
Cool. So we have just talked about multi-geo, and again, we're off the end of the resiliency spectrum. We're now just talking about regulatory and jurisdiction issues. But end-user proximity can be an issue. In particular, in China, it's an issue because the firewall in China means that access for Chinese users outside of China, so services located outside of China, can be spotty, and it's always slow. And so this is one way of getting proximity to users. Now, the next picture is quite interesting, and it introduces a whole different scope of complexity. And this is really about a hybrid deployment. So with a hybrid deployment, we're now looking at a deployment that could be in a single or multiple regions in Azure, and also lives in one or more data centers that you either own or lease, or perhaps that are provided by a hosting partner, like in the CloudOS network. And so this is quite an interesting picture, a bunch of new concepts. So, Yigal, why don't you take us through?
Thank you. So what are we trying to solve here? One scenario which we hear quite a lot is about extending existing app to the cloud in order to get better availability. Either disaster recovery or just ultra high availability. Whatever happens in my own data center, The application is not impacted, application is always on, it's running in the cloud. And you might debate about which components should be running in the cloud, which components should only be running locally. You may debate whether load balancers should be in the cloud or not. You may debate whether you want to replicate your Active Directory to some kind of read-only replica within the cloud. But still, this is high level, this is a scenario that many of our customers are considering. This is an easy way to make your application redundant without really paying for the cost ultimately. In some cases, even spinning the capacity when you need it. Not even keeping it alive other than maybe one instance, and spinning it once more customers are starting to use the public cloud portion. And of course, you may want to fence it. You may want to fence your systems from outside world. The same VNet configuration applies, but the other consideration to take into account is how do you connect this VNet to your network? How do you make sure that your enterprise network extends to this limited island within the public cloud that is relevant to your organization, that is part of your organization? And for that purpose, we are using ExpressRoute. What's ExpressRoute?
ExpressRoute is a service that lets you have a private connection through a telco provider to Azure. And there are a couple different models. If you already have a telco who links up your branch offices, you can just have them connect up to Azure. If not, you can use a hosting partner like Equinix and connect to them, and then have them connect to Azure. And so you'll have a set of redundant, dedicated circuits for your use. And then in the cloud, you can have a deployment with a VNet that becomes this virtual extension of your on-premises network. I'll mention, and there are other talks with many more details today, but there's a variety of new stuff with VNets. In addition to network security groups that we released earlier this year, we've now announced, I think last week or this week, we're announcing user-defined routing, which lets you force traffic inside of a subnet in your VNet to go through an appliance, for example. And there are a variety of different appliances that you can run inside of a VM in the cloud to do things like firewall, packet inspection, intrusion detection, et cetera. They have multiple NICs, and so they can create for the variety of different network topologies that you might be already using in your on-prem deployments in the cloud. And so you can have a very secure and closely managed cloud VNet deployment using many of the same technologies and vendors that you use on-prem already.
Yeah. So this funny triangle with circles on the edges, it's a symbol for ExpressRoute. Another thing that is illustrated here, the machines inside the cloud are connected to the domain controller. So it's really still the same management domain, same network. It's really an extension. It's really should be designed as an extension of your existing enterprise network, or potentially your existing enterprise data center. And of course, various organizations will consider various compliance levels required, what can be going to the public cloud, what's not. But it's definitely an easy way to add high availability to your app. Furthermore, you can design new features in your app or new capabilities just by adding capacity in the cloud does the work. Once again, could even be temporarily, just on an as-needed basis. You might consider going to new regions. Locality for worldwide enterprise, global enterprise, might want to add locality instead of just relying on a couple of central data centers, which might not have the best response time to all the locations. Mm-hmm. Burst, definitely an issue that can be solved here. Sometimes I mentioned retail, but that's an easy way for retail to extend the local owned data center just by adding capacity as needed. And even that capacity can be managed automatically using scale sets with IaaS.
And actually, last week we spoke with someone who had just worked with a customer to deploy Burst using IaaS into the cloud. And what they did was they wired up a set of scripts that were running in Azure Automation with F5 PowerShell commandlets, so that every single time a VM was spun up in the cloud, that VM would automatically be added to a load balance pool for the on-prem load balancer. And so they'd sort of stitch together this scenario so that they would have the the elasticity without the costs of owning all of the hardware in the cloud, and yet they could still use this on-prem networking setup that they trusted and that they used for a bunch of their business processes.
So one of the things that was traditionally hard here, again, is the data layer. But I think we came with a cool feature, which was G8 just a week ago. Premium storage. Why? So one of the ways to use hybrid solution here is to have some kind of SQL server running in the cloud, basically IS SQL server, and this server can be used, can be synchronized with your local database, your own, whatever database you are running in the enterprise, your own choice. It could be, by the way, not necessarily Microsoft SQL, it could be Oracle or any other server. So one of the cool features we just added, premium storage, will allow us to guarantee the I/O rate for the database, and this was a critical issue when running database in the cloud. This essentially enabled those scenarios, enabled those SQL always on and other scenarios where we can really guarantee that there is enough I/O capacity for the database to operate. You still need to take into account all the multi-region considerations we talked about in the previous slides. It's still not transparent. It's still not completely transparent. But this definitely allows you to run this application in a much more robust way.
And the performance on this is actually excellent. If you provision the right number of data disks on your VM and you choose the right VM size, you can get up to 50,000 IOPS, which is the most IOPS that you can get from a single VM from any cloud vendor to a durable drive. And so it really does unlock many database scenarios that were previously blocked with standard storage. The thing to note about premium storage is that premium storage does not give you the ability to do georeplication for your premium storage accounts. So if you care about disaster recovery for the data that you've got on those disks, you've got to create snapshots in standard storage, and then you can use standard storage to georeplicate across. The other concern there is when you create the snapshots, you've got to think about how to make those snapshots consistent at the application level. So this is a place where VSS can help you, and so you just have to be aware of that and manage that snapshotting yourself.
Cool. Of course, if you want to punch holes in your VNet in this configuration, you may still do so, and it's completely up to you to manage. It's completely up to you to manage the access to your public deployment in the same way you manage access to your enterprise deployment. If some pieces of the applications need to be accessed externally, it's still possible to use either Azure load balancers or your own load balancers, either Azure Traffic Manager or your own Traffic Manager, and route both external and internal users within your organization. The bottom line, it could be as open as you want it to, in the same way your data centers are as open as you want them to. It really should be seen as an extension of, in some cases, an extension of your data center, or even the other way around. We do have some customers who are primarily based in the cloud. And those customers extend their service into local data centers only in certain cases of compliance, certain applications which require certain levels of compliance or critical business advantage run inside own data centers, and all the rest is within the cloud, right? Yep. It's a valid model, definitely much more cost-effective model to operate, given the ability to spin up and down additional instances.
Yeah. And I think, okay with you if I jump to the next picture?
Sure.
I think the interesting thing here is there's sort of this, there's a flaw, I think, in the way that we approached the design of the application from the beginning. That application design works really well if your application is born in the cloud. But many applications have already started on premises, and people are thinking about how to cloud enable them. And it's a completely different path in the case where you start off with an app that's on-prem, figuring out how to make it hybrid. And in many cases, the choice of making it hybrid is based around this, like a set of key features that you might start to adopt in a very incremental way to bring your application into a cloud. It could be that you struggle to do key management on premises. And Key Vault might be a much more fully featured and inexpensive way to do secure key management or compliant key management in the cloud. So you could have a completely on-prem deployment with your keys in Key Vault. Or you might choose to use Store Simple to migrate your storage up to the cloud and have effectively an infinite file share on premises. I should note Store Simple is not just about files, it's about blocks, so you can use it for many different scenarios. But that's one way that people like to sort of get started moving to the cloud. Another thing, I was talking this morning on the bus coming over to the conference center with a fellow who runs some services that are replicated across multiple data centers using Hyper-V. Azure Site Recovery can be a great choice for these applications to give you a DR capability to the cloud that enables you to sort of replicate and fail over your VMs from on-prem to the cloud. It's not just about disaster recovery. It can also just be about migration. It substantially simplifies migration, and that's a scenario that some people are going to be talking about this week in more depth. Another note about hybrid deployments is we mentioned before that there could be these failures at the Azure platform level that could be global. If we have a time-related bug, for example, that's one of those things that can affect us. By running a service that's a hybrid service across an on-prem deployment and an Azure deployment, you really end up having the ultimate in redundancy because you now have provider redundancy. And so even if all of Azure were down, your application could remain available based on the on-prem portion of the deployment. Or vice versa, if your on-prem services failed catastrophically, you could continue to run the pieces that are in Azure and provide service to your customers. So one reason that people might choose to do hybrid deployments is actually to protect themselves from these major failures. Oftentimes, that's not the reason that they start. They start because they want just an extension of what they've already got on-prem, but this can actually be a strategy that some people use. And I know that Microsoft's own IT division has done this in certain circumstances. We have well, it's changed more recently, but we have a performance review process that uses a set of systems that we manage internally, and there was a period of time where those systems, and it may still be the case, are deployed in a redundant configuration on-prem and in the cloud, and we've had outages on both sides. And that's really tough when it's the day before reviews are due because everybody's pounding on those systems at the same time, and so it's really nice to have the ability to run across both. And so, when we talk about hybrid technology, there's a variety of connectivity-related things, some management things, some specific workloads that could be hybrid. And then there's also this notion of what platform are you running on for the portion of the services that run on-prem. It could be, again, your own data centers. It could be a host served in the Cloud OS network. And so there are a variety of options there. And I don't think either of us is an expert in it, but we now offer this cloud platform system, which is a combined sort of hardware-software appliance to run Azure workloads, and the Windows Azure Pack, which is this experience on top of Hyper-V that gives you a portal essentially consistent with the portal that we have in Azure for a subset of the workloads that we offer. And so you can do sort of self-service, chargeback-based deployments on premises using the same models that run in the public cloud. So you build something once and you can deploy in multiple places easily. So there's a huge investment in hybrid, and I would say actually this is one of the areas where Azure is differentiated from the competition in a big way because we are super friendly to hybrid, this sort of Microsoft's legacy and heritage.
Cool. Any questions on what we discussed until this point? Yeah.
A couple of questions.
Sure. Can you use the mic? Yeah.
Two questions. The first is, when you're going from within a region, the regional pairs, what are the network components that you need to create that virtual network between the two sites, and does data go in and out of the cloud so you get charged for that?
Yeah.
The second question is, are you going to talk about backing up and backup strategies for cloud-based solutions that just survive in the cloud?
Yeah. Good questions. So on the first question, I think the question is, what does it take to have a wide VNet that crosses multiple regions? What are the networking components that you need to think about and how to set it up? So the first thing that I will say is that neither Igal nor I works on networking, and so we're probably not the right people to give you the definitive answer on this. But to the extent that I know about it, I believe what you need to do is create 2 VNets, mark both of them as wide VNets, and I think what you do is you configure gateways on each of them, and it effectively creates a VPN between those, a secure VPN between those. Now that VPN is running across Microsoft's backbone because it's cross-region traffic. And I think you just pay cross-region charges.
Yeah, there are definitive guides on the web about how to do it, but it's 2 VNets which are connected together. That's the concept.
Yeah.
And you might add your appliances in the middle. So we have bring your own appliance
That's right.
scenario now, and you should take a look into those. You might think about adding some virtual appliances. We partnered with some large folks across the industry to allow those scenarios. So it's really open to your needs. The most basic scenario is two VNets connected together.
And one thing that you might check out, there's a talk by Ganesh Srinivasan, and he's going to be demoing a bunch of hybrid networking stuff, and he's kind of an expert on some of this, and so he could talk about what it would take to do VNets across regions. He's sort of the first guy that I would point you to, and he's here and he's talking. You can find him. You can also find us at the Azure booths. So we will get you an expert on VNets. Now, I think the second question was on backup strategies and what do you recommend for backup strategies. And I would say when it comes to backup strategies, backup is an area where we at the platform layer have learned consistently that it's really important to use it or lose it. If you are taking backups and you never restore those backups, you can bet that when you attempt to restore the backup, it is not going to work for you and you're going to be very disappointed. In fact, what we do now, and I think she was here, she may have stepped out, a member of my team, Hongfei, who's also giving a talk. Here she is in the back. Hongfei's team now runs, every single time we have a new region in Azure, one of the things that we do is we open up the region for private preview, and we have customers come on board. And then as soon as we brought them on board, we say, hey, we're going to take this region down while you're running on it, and see how it works out for you, and we'll see how it works out for us, and when we find problems, we'll fix them. And every single time we do this, it's a big education, because we find issues that nobody anticipated. Some piece of software doesn't fail over the way that you expected, or customers expected the platform to do things that it doesn't actually do, and that they're responsible for doing more. So I would say, understand the scenario that you're trying to protect. Are you dealing with a situation where you're trying to protect against data corruption? Are you dealing with a scenario where you want to roll back changes that a user made in error? Are you dealing with a situation where you want to be able to restore service when there's a platform outage or a regional disaster? I think if you understand the scenario you're protecting against, you can pick the right RTO and you can pick the right scenario. And then once you pick that scenario, you've got to exercise it. We have a variety of services that we offer to try to make things easy. There's this IaaS backup offering that's part of the platform offering, and so it installs a VM extension that helps you take consistent application level backups, and then you can have those backups in storage and you can replicate them to a second region if that suits you. But then it's your job to make sure that that you restore those backups and validate that things are working at the application level. So I would say we actually have some criteria that we use across all of our platform components to make sure that they are addressing resilience in the right way. And anytime there's any backup at all, our sort of gold standard is that there's an automated system that retrieves those backups on a regular basis, like monthly, and restores them and makes sure that they're consistent when they're restored.
So maybe I can elaborate also on another aspect here of backup restore as a whole. And there's one other guiding principle that we are using for, I think, all our designs, and you may imagine the scale of our designs. We are trying to avoid, if possible, the scenario where we need to back up and restore. The best scenarios that we look at is having some smaller stamp, another smaller stamp that is always on, that is always running and monitored. And the only thing we need to do in case we have any issue, we will increase the size of that other stamp or add capacity to it versus starting restore and backup operations. So this is hard because you need to take into account how the data is replicated and to make sure that it's always on. It might tax your performance. But this is the scenario that at least guarantees whenever you need this, it's working because you validated it's working again and again every minute of every day. Versus restore backup, which is a process that you need to take when issues arise. So backups without exercising are limited in value. But keep that in mind.
But backup is really the only game in town if what you want to deal with is to protect against some kind of data corruption bug that you might not notice until later.
Definitely for
and
data.
At that point, if the only thing you had was your one live copy of the data, game's over.
Yeah,
and that's where you have to have backups.
For data, it's the only game in town. Yeah.
More questions?
So how is the Store Simple and premium storage is connected? And for premium storage, are you guys using any kind of a flash storage to deliver that 50K IOPS per VM?
So Store Simple is an appliance that you run on premises, and that appliance can act as effectively as a local SAN, and then it uploads to the cloud. And I believe, and I don't work on Store Simple either, so we can find the Store Simple folks who are also here this week to give the perfect answer here. But I believe that they upload to standard storage. You could copy data from standard storage into premium storage and then run in the cloud using premium storage. And what Store Simple would do for you is it would ease the process of getting the data up into the cloud. But then once in the cloud, you would be responsible for transferring it from effectively one storage account to another storage account, from the standard to the premium account. Now, premium storage is based entirely on SSDs. So we build out physical capacity that's SSD-based, and then we offer this premium storage service on top of it, and it exposes those SSDs. We also, by the way, offer SSDs as local ephemeral disks in many VM sizes. And so if what you want is a local cache and you don't need it to be durable, you can use those VM sizes to get that SSD access that way. I don't know if this... I'm sorry, it's hard to hear. We'll force you back to the mic.
Yeah, sure. So once my data moves to the Microsoft Azure cloud, what happens to the Store Simple? It's an appliance, right? So once you transfer data from on-premise to the cloud, so what happens to that appliance thing? So will it help in integrating private on-premise and on public cloud as a hybrid model?
Sure. So my sense, and again, not working on Store Simple, I will plead a little bit of ignorance on this, but my sense is that when people deploy Store Simple, they deploy it as a local SAN for a local workload. And it will also give them the benefit of replicating that data to the cloud. So they get effectively infinite capacity on that local SAN, which has a variety of policies for smart management of which data stays local, which data gets uploaded, how up-to-date should it be, managing the sort of the performance and the cost trade-offs and capacity trade-offs there. And most of the time, that appliance continues to run in conjunction with other services that you have on-prem. So you might have VMs with data that is stored on that appliance, and those VMs are running all the time accessing that appliance. Now, having the data up in the cloud, A, it gives you disaster recovery in the event that there's a failure in your local data center, and B, it sets you up to be able to enable new workloads using the same data as cloud-hosted workloads if you'd like to. So I think very few customers use Store Simple solely as a means of getting data up into the cloud. Most customers use Store Simple because they want it for some on-premises workload, and then it gives them this cloud benefit that can lead to other things over time.
Do you publish the latency between the geo-spread out clouds?
Do we publish the latency between the geo-spread out clouds?
Or basically, do you guarantee, let's say if I were to ask you, between the US cloud and the South Asia, I need this latency and this is the only acceptable latency. Is that guaranteed?
We do not offer guarantees on cross-region latency. We find that varies so much based on the state of the physical network over time. There are undersea cables, they can be congested, there can be cuts, all of these things. But if you have specific requirements around cross-region latency, I'd love to hear about it. Maybe we could chat afterwards. Yeah. That's an interesting topic.
Cool. So let me mention that there is the Ignite Azure Challenge.
Yes.
If you attend Azure sessions and activities, you'll track your progress online. You can win some raffle tickets and win some prizes. Some of the cool prizes are here, and you see the counts of prizes. So you have really good chance of winning. Just continue attending those sessions, and we just shared in the previous slide what are the sessions which are relevant to this discussion. Thanks a lot for the time. I will be during the day in the booth on and off, so you can find me there. My business cards are here in case you want to establish contact and follow up with questions. Thanks a lot for joining, and thanks for coming.
Yeah, and come find us at the front. We probably have a minute or two until we have to leave, and we can even hang out in the hallway afterwards. We'd love to take more questions. Thank you very much.
Thank you.